Hello all. In this session we are discussing about decimal to binary and binary to decimal. First we will see decimal to binary. The procedure here is divide the decimal number by 2 and record the remainder. Divide the quotient obtained by 2 again and record the remainder. Do this process continuously until the quotient becomes 0. Take the remainders bottom to top. We will see an example. 11 is to be converted into binary. Decimal 11 is to be converted into binary equivalent. So divide the decimal number by 2. So we will get the quotient as 5, and that means it will go 5 times and the remainder is going to be 1. Again divided by 2, it will go 2 times and the remainder is 1. So we are recording the remainders also. Then continue this procedure. Divide 2 by 2, so we know it will go once, so the quotient is 1 and the remainder is 0. Again divided by 2, it will go 0 times and the remainder is 1. Now we have the quotient as 0, so we can stop it here and take the remainders bottom to top. So 1 onwards we have remainders. Take the remainders bottom to top. So we'll be getting 1, that is this one, then 0, then 1 and this 1. So 1 0 1 1 is the binary equivalent of decimal 11. So we'll have to represent like this: 1 0 1 1 to the base 2. We will see another example. Suppose we want to convert 53 into binary. 53 to binary. So the procedure is 53 divided by 2. It will go 26 times and the remainder is 1. Divided by 2, it will go 13 times and the remainder is 0. Quotient is now 13. Divided by 2, it will go 6 times and the remainder is 1. Divided by 2, it will go 3 times and the remainder is 0. 0. Divided by 2, it will go once and the remainder is 1. Divided by 2, now the quotient has become 0 and the remainder is 1. Take the remainders bottom to top. So we'll be getting 1 1 0 1 0 1. So the binary equivalent of decimal 53 is 1 1 0 1 0 1. Now we will see how to convert a fractional portion decimal number or a fractional decimal number to binary. The procedure is: multiply the fractional portion by 2, record both integer and fractional portions. Take the fractional portion and multiply by 2, record integer and fractional portions. Continue this procedure until we get fractional portion equal to 0 or to a certain number of times. Then take the integer top to bottom. We will see an example. Suppose we want to convert the fractional 0.6875 to the base 10 to its corresponding binary. So take the fractional portion, that is the number itself. Here the number is only fractional, we have only fractional part here. So just multiply that 0.675 into 2, so we'll be getting 1.3750. Okay, so this is the integer portion, this one is the integer portion, and this is the fractional portion, that is 0.3750. so take the 0.3750, that is the fractional portion. Again continue multiplying. 50 into 2 will give 0.7500. Fractional portion is 0.75. Take that into 2, so we'll be getting 1.5. You can extend the number to any number of position by appending the zeros. Okay, so which does not make any change in the value. Again take the fractional portion, that is 0.5 into 2, so that will give 1.000. You see now the fractional portion has become 0, so we don't have to continue. The meaning is that even if we continue, we are going to get in the next iteration both integer portion as well as fractional portion are 0. So we can stop it here. Now the remaining thing is take the integer portion, that is this portion, top to bottom. So the binary equivalent of 0.6875 is 0.1011. We have taken the integer portions top to bottom. So this is this one, and this is 0, and this is this one, and this one is this. Don't forget to put the decimal point there, then this is the answer. And please do remember that always we are not going to get the fractional portion as 0. On such occasions, after some iterations, after some steps, we can stop. Okay, we will see another example. That is 0.7125 is to be converted into its corresponding binary. The procedure is 0.7125, that is the fractional portion, into 2, we will be getting 1.4250. Take the fractional portion, that is 0.4250 into 2, so we are going to get 0.8500. Take the fraction portion again, then multiply into 2, so we are going to get 1.7000. Take the fraction portion, that is 0.7000 into 2, so we are going to get 1.4000. Take the fraction portion again, so we are going to get 0.8000. Take the fraction portion again, 1.600. Now we know that by multiplying the fractional portion by 2, we are never going to get zeros in the fractional portion. So it is enough to do this much. We have done enough times. the reason why we are stopping here is, even if we continue, we are not going to get fractional portion as 0. So it is enough to do up to here. Now we can take the integers top to bottom. So the equivalent is going to be, we should place the point in the first position, 1 0 1 1 0 1. Hope it is clear for you. Now we see a mixed decimal number, that is a decimal number which has integer portion as well as fractional portion, and will convert it into its corresponding binary. Let us take the example of 13.5250. This is to be converted into corresponding binary. We know how to convert integer portion into binary, and also we know how to convert fractional portion to binary. So first take the integer portion, that is 13. Here we have to divide by 2, continuously by 2, record the remainders until we have to go through this procedure until we get the quotient as 0. Then take the remainders bottom to top. So do that procedure, divided by 2, it will go 6 times, and remainder is 1. Quotient is 6, divided by 2, it is going 3 times, and the remainder is 0, and divided by 2, and we are going to get 1 as quotient, and the remainder is 1, again divided by 2. So now the quotient has become 0, remainder is 1. So we can stop it here since the quotient has become 0. Now take the remainders bottom to top. So we will be getting 1 1 0 1. So decimal equivalent of, binary equivalent of decimal 13 is 1101. Now we have to see the fractional portion as well. To do that, 0.5250 into 2 will give us 1.05. Then 0.05 into 2 will give us 0.10. Then 0.10 into 2 will give us 0.2. 0.2 into 2 will give us 0.4. 0.4 into 2 will give us 0.8. 1.6 will give us 0.8 into 2 will give us 1.6. again 0.6, taking the fractional portion, 0.6 into 2 will give us 1.2. So even if we continue, we are not going to get fractional portion as 0. So it is enough to do up to here. Now take the integer portions top to bottom. So we are going to get 0.5250 has a binary equivalent. Don't forget to place the point in front, then take the integers top to bottom, 1 0 0 0 0 1 1. Okay, now we'll have to combine both fractional as well as the integer portion, which is 110. So I am going to write it together. So 13.5250 decimal has an equivalent binary 1101. This is for 13. and for the fractional portion 5250 has 1 0 0 0 1 1 and give the base as 2. So this is going to be the answer. Try your own examples, and if any doubt, don't hesitate to ask me, ask doubt in the comment box. Okay, thank you. Now we will see how to convert a binary number to decimal. Binary to decimal. Okay. Before entering to an example, we will just revise the positional weights by taking an example. This is a binary number and its weights goes like this. This position 2 raised to 0, this position 2 raised to 1, this position 2 raised to 2, this position 2 raised to 3, and this position has a weight 2 raised to minus 1. Remember, it is the other side of the decimal, and this is 2 raised to minus 2, and this 0 has a weight of 2 raised to minus 3. So regarding this portion we have already discussed in our previous classes. You can check that class, and the link is given in the comment box. So when it comes to this portion, 2 raised to minus 1 is 1 divided by 2 raised to 1, that is 1 by 2. So this is half or 0.5. 2 raised to minus 2 is 1 divided by 2 raised to 2, that is 1 divided by 4, that is 0.25. Then 2 raised to minus 3 is 1 divided by 2 raised to 3, that is 1 divided by 8, it is 0.125. And 2 raised to minus 4 is 1 divided by 2 raised to 4, that is 1 divided by 16, that is 0.025. If we know these things, it will be easier for us to convert the numbers into decimal numbers. So we will see an example. Suppose we want to convert the number 11101.011 to decimal. Okay, and the procedure is there are only two digits or symbols occurring in the binary number. We know that. Just if it is 1 into positional weight, and if it is 0 into positional weight, then sum up all the individual ones, then we will be getting the answer. We will see with an example. Okay, so the positional weight we know already. This is 2 raised to 0. I am writing it again. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3. So first we will take the integer portion. So it is going to be, as we know, this one. So we are putting the equal sign to find the decimal number. This one into 2 raised to 4 plus this one, second one, that is 1 into 2 raised to 3. We are just multiplying with the positional weight, that's all. Plus this 1 into its positional weight, that is 2 raised to 2. 1 into 2 raised to 2 plus 0 into 2 raised to 1. I hope you are following me. Plus 1 into 2 raised to 0 plus 0 into 2 raised to minus 1 plus 1 into 2 raised to minus 2 plus 1 into 2 raised to minus 3. 0 into 2 raised to minus 1, that is this, that 1 into 2 raised to minus 2, this one, and the last one is 1 into 2 raised to minus 3. Again, now just find the sum. 1 into 2 raised to 4, that is 16 plus 1 into 2 raised to 3, that is 8 plus 1 into 2 raised to 2, that is 4 plus 0 into 2 raised to 1. Any number raised to 1 is that number which we know, but since it is 0 here, it is 0 here. 1 into 2 raised to 0, any number raised to 0 equal to 1. So it is 1 into 1, it is 1. Then next we have 0 here, 0 into 2 raised to minus 1, so it is going to be 0. Then 1 into 2 raised to minus 2, we have already seen that it is 1 divided by 2 raised to 2, that is 1 divided by 4, and this is 1 divided by 2 raised to 3, that is 8. So we know these numbers, so it is going to be 16 plus 8, 24 plus 4, 28 plus 1, 29. So this integer portion we are going to get as 29. Then what about these numbers? 1 divided by 4 is 0.25, we know that. 1 by 8 is, that is 0.125, 0.125. So just appending a 0, which is not going to make any change in the value. So it is 5, it is 7, 3. So it is 29.375. So this is the equivalent decimal number. Hope it is clear for you. Okay, we will see one more example. That is 110.101 is to be converted to decimal. So I am not going to write the positional weight this time, and I think you have already understood. What is this position? This is 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2. So 1 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0 plus this is 2 raised to minus 1. So 1 into 2 raised to minus 1, 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3. Okay. 1 into 2 raised to minus 1 plus 0 into 2 raised to minus 2 plus 1 into 2 raised to minus 3. So this is 1 into 2 raised to 2, that is 4. This is 1. Sorry, this is 2, and this is 0. Okay. And what about this number? This is going to be 1 by 2, and since it is 0 here, this 0 is up here, then this is 1 by 8. So we are going to get this as 6. Okay. Then what about this position? This is 0.5. Half or 1 by 2 is 0.5, we know, plus 1 by 8, that is 0.125. So we are going to get 0.625. So this is the decimal equivalent of this number. So when you write the answers, you'll have to write like this 110 6.625 to the base 10. This is how you'll have to write the answers. Okay, hope it is clear for you. If you have any doubt, don't hesitate to ask, and if you have any comments, please post it in the comment box, and if you have any suggestions too, you can post it in the comment box. Please do subscribe it, and see you next time.